Hello, good morning once again. I come to your homes with our virtual learning. I hope you're all doing well at home. I entreat all of you that you participate and take whatever we are giving to you seriously. All hands must be on deck. Take it as if we are with you, having that facial engagement with you. Read your books at all times and be good children at home. Today, PS 5 and 6, what we are going to look at, we are looking at a new topic called sex. Sex. The first thing is this. I want us to look at just three things. What I want us to look at is, what's our sex? That's the first question I want us to look at. Why do we need them? And how do we represent them? I said that we are going to look at sex. I want us to know what are sex. I want to also let us know why we need them and how we represent them. At the end of the day, you understand. When you have the concept of what they are, why we need them, and how we represent them, we'll get the concept right. For example, I want us to quickly write down the things that we can see. Things that we can see. What are some of the things we can see around you? Alright. You see, you can see a tree, table. Good. Chair. Alright. It's okay. Let us also try and write the things we cannot see. Things we cannot see. What are some of the things you cannot see around you? Oxygen. Good. Hydrogen. Nitrogen. Somebody even said ghost. Good. These are things we cannot see. What I mean that we have been able to collect down things. Is that not the case? Good. So here, as I said, what are they? So we've been able to collect things. So in this case, when we are talking about sex, it's the first thing that comes in mind is that it's a collection of things. Good. Let's also try this. Let's assume that the first word is collection. I want us to write the oceans in the world. Oceans in the world. There are 5 oceans in the world. And what are they? We have the Pacific Ocean, the Indian, the Southern, then we have the Arctic. Then the last one that we have is Atlantic Ocean. These are the 5 oceans that we have in the world. Good. Now, when we talk about sex are things that could be collected, and not just necessarily collecting them. Whatever you collect must have a bearing or it must be related. So in collection of sex, the things that you collect must be related. So, without wasting much time, I want us to look at this. For instance, when I tell you, get me the set of good teachers, it is impossible. Your way of identifying a good teacher might be different from mine. The same way when I ask you, get me the set of intelligent students, your way of getting or probably identifying intelligent students will differ from mine. So that is impossible. In the last, what I want us to talk about is simple. Now, let's look at what a set is or what are sets. A set is a collection of objects that are well defined and related. A set is a collection of objects that are well defined and related. As I said earlier, it should be something that is, we collect them and they must be related. It's a collection of objects that are well defined and related. Good. On that note, let's also go on with types of sets. Types of sets. I want us to look at the types of sets that we have. Now, one, we can have what we call empty set or null set. We have what we call unit or singleton set. I believe you get it. We have what we call finite set. Then infinite set. We can have what we call equal set. We can also have what we call equivalent set. We can have what we call universal set. Good. We can have what we call also subset. Then we can also have what we call proper subset. Then we can have what we call super subset. Good. So again, the types of sets, we can have what we call empty set or null set. We can also have what we call unit or singleton set. We can have finite set. We can also have what we call infinite set. We can have what we call equal set. We can also have what we call equivalent set. We can have what we call universal set. We can have subset. And out of the subset, we can have what we call proper set, proper subset, and super subset. Let's take them one after the other. Good. Good. Let's take it for instance, number one. Empty set. Empty set. Even the name speaks volumes. The name, it speaks a lot of volumes in your ears. Empty set. So what is it? This is a set with no element. Empty. A set with no element. An empty set is a set with no element or member. Good. Let's look at the symbol of an empty set. The symbol of empty set is this. a null set. Empty or null. Good. I believe you have gotten it. An empty set is a set with no element or member. And this is the same. So I can have set A to be like this. So this means that set A has no element. And that is termed as an empty set. Good. Number 2. We spoke of unit or singleton set. Unit. What is it? The word unit or single. Yes. A set with only one element. This is a set with one element. A set with one element is called a unit set. So I can have set X to be 3. The cardinality of set X is what? How many elements do I have here? It's only one element. So a set with only one element is termed as a unit or a singleton set. Good. We spoke about what we call finite sets. This is a set with a limited element. With a limited element or member. Good. So I can have this. Set F is equal to counting numbers less than 6. Counting numbers less than 6. Here you could see that the set is being defined with a limit. It says that the set F, there should be counting numbers. That is the first rule. And these counting numbers must be less than what? 6. So then, if set F should be counting numbers less than 6, what are the counting numbers that will be less than 6? Yes, 1, good. 2, 3, 4, and 5. A set with a limited element. There is a limit for you. And for that matter, any set that is not defined with a limit is termed as a finite what? Set. A finite set. Good. Again. Set M is equal to even numbers between even numbers between 6 and 18. Again, set M is being defined to be even numbers. And these even numbers, they expect them to be between what? 6 and 18. In between 6 and 18. So what are the even numbers you can find between 6 and 18? You can have 8, 10, 12, 14, and 16. So this is also a finite set. Good. Let's go on with what we term as infinite. This is a set with unlimited elements. A set with unlimited elements. Infinite set. A typical example. Set P is equal to counting numbers. The person just said that set P should be counting numbers. We can count and we can even get to the infinity. So if set P is counting numbers, what would they be? 1, 2, 3, 4 to infinity. A set of such nature is termed as an infinite set. Good. On that note, let's go on with what we call equal sets. Equal sets. Equal sets are sets with the same elements. These are sets with the same elements. A set with the same element. It means the elements look alike. For example, I can have set A to be 1, 2, 3, 4. I can also have set B to be 3, 2, 1, 4. Good. Let's look at these two sets carefully, critically. Now, the cardinalities of set A, meaning the elements of set A, let's go 1, 2, 3, 4. It has 4 elements. Set B, the cardinalities are also 4. 1, 2, 3, 4. We have 1 in set A. The same applies to when it comes to set B, we can also find 1. We have 2 in set A, we can find 2 in set B. We have 3 in set A, we can find it in set B. We have 4 in set A, we can also find it in set B. It's just that the arrangements differ, but the elements are the same. So 2 sets which have the same element is termed as equal what? Set. Let's take another example. Set M is the set of the letter is the set of the letters. The set of the letters in the word earth. Set K. Let's even look at the first one carefully. Alright, let's add it. Set K is the set of the letters in the word heart. Heart. When we look at set N, now let's look at the two questions carefully. Set N is the set of letters in the word what? Earth. So when we look at set S, it says it contains the letters in the word what? Earth. So you have E, A, R, T, and what? H. These are the letters in the word earth. Set K is also the set of letters in the word heart. You have H, E, A, R, and what? T. When we look at these two sets carefully, we can see E in set S. E could also be found in set K. A in set S. A could also be found in set K. R here, R there, T here, T there, H here, H here. It's just that the letters are misarranged when we come to the two sets. But just that the letters look alike. That is what we call equal set. Then we come to good. Now we know what equal sets are. Let's go on with what we call equivalent set. Equivalent set. We said that equal sets are two sets which have the same element. We are looking at equivalent set. Is the opposite of equal set. For that one, they have different elements, but the same number of elements. These are sets with different elements, but same number of elements. For example, let's assume I have set A to be 1, 2, 3, 4. Set B to be 5, 6, 7, 8. What is the number of elements in set A? How many elements are in set A? Let's count the two. 1, 2, 3, 4. There are 4. Good. Let's also check that the number of elements in set B. 1, 2, 3, 4. That one too has 4 elements. But their elements are not the same. They differ. Set A has 1, 2, 3, and 4. And while set B has 5, 6, 7, and 8. They are two different elements altogether. But in terms of their number of elements within each set is the same. This set A has 4 elements. Set B also has 4 elements. But their members are not the same. And that is what we term as equivalent set. Good. Let's look at what we call universal set. Good. Now, universal set is the set containing all the elements. This is the set. Containing all the elements. All the elements, and of which all other sets. And of which all other sets are subsets. What does it mean? The symbol of universal set is capital U. That's the symbol of universal set. And universal set is the set containing all the elements, and of which other sets are also subsets of it. Good. Let's take something like this. U contains the vowels, the English vowels. And let's say it also has this. The members of set A could be found in the universal set. It means that set A, it contains all the elements. Then again, we are saying that which other sets are also subsets. We can also see that the members of set A, which is A, E, and I, they can also be found in the universal set. So we can say that set A is a subset of what? The universal set. Good. This brings us back to what we term